Shall we begin?
Yes, sir.
Okay, great. Three-dimensional geometry. So we have also discussed a little about it in the vectors chapter, but we are going to discuss about it more here. So as we have discussed about direction cosines and direction ratios earlier also, but this time we will understand it from the perspective of a 3D Cartesian system. So this is our three-dimensional Cartesian system. Let us assume there is a line. So first let's talking about the same concepts that we have discussed in the chapter, that there is a vector. This is a vector. So this is a vector. Vector A. So vector A is A1 I cap plus A2 J cap plus A3 K cap. Its direction ratios are basically its coefficients A1, A2, and A3. C, direction ratios. So we are talking about direction in some sense. They will be giving us the direction. We discussed about direction cosines. They were actually L, and N. L, M, and N being cosine of alpha, where alpha is the angle made by the x-axis. Cosine of beta. Beta is the angle made by y-axis. And cosine of gamma, where gamma is the angle made by z-axis. So these are the direction cosines. But there is one thing to catch here, is that when we're talking about vectors, we can draw the angle like this. Okay, fine. But what if we discuss about a line, straight line, like same as this? Let me take this. So there's a line having same everything. Its direction is same. But this time, the angles can be drawn in two ways. One is alpha. Okay, great. Another one way to draw the angle with the x-axis is this angle, which will be pi minus alpha. So there will be two direction cosines for x-axis, cos alpha and cos of pi minus alpha. Similarly for y-axis, cos pi minus beta, cos pi minus gamma. These will also be the direction cosines. For a line, we are talking about a line. So now we can summarize and write that plus minus cosine of alpha, because cos of pi minus alpha is cos of minus of cos of alpha, right? Cos pi of minus theta, cos pi minus theta is minus of cos theta. That is why we can write it plus minus cos alpha plus minus cos beta and plus minus cos gamma. That's the only difference for a line, that the direction cosines have double signs. And even in NCRT, there is only positive sign given. So direction cosines tell us about directions, and they are typically the coefficients of unit vector, or should we say the cosines of angle made by the line of the vector with positive x, positive y, and the positive z. Direction ratios are ratios. They also tell us about the directions, but they do not tell us exactly about the angles made with, with the axis. So is this point clear about direction ratio and direction cosines? Any doubts? Yarini,
Yes, sir.
any doubts?
No, sir.
Okay. We have already discussed that cosine square of alpha. Let me also write it again. That if we square and add the direction cosines, they will give us 1. Or cos square of alpha plus cos square of beta plus cos square of gamma is going to give us 1. And talking about the direction ratios, they can be there can be infinite direction ratios. Like direction cosine can also be referred to direction ratios. But what is specific about direction cosines is that they are the cosines of angle made by the axis with the line of the vector that we are referring to. So that's one unique thing about direction cosine. Direction cosines are unique. Direction ratios can be multiple. So if that is clear, let us now move ahead and discuss about the direction cosines of a line when we have two points on the line given. This is a line given to us, and there are 2 points given on the line, A and B. A points coordinate are x1, y1, and z1. And B points coordinate are x2, y2, and z2. Yes. Okay, these are the only two things that we have. And we have to find out the direction ratios and direction cosines of the line. So for direction ratios, as we know, in vector, what we need to do, we find a position vector AB by uh, by subtracting the position vector of B minus position vector of A. So we will come out as x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. And the coefficients will be the direction ratios. So direction ratios are simply x2 minus x1, y2 minus y1, z2 minus z1. These are the direction ratios. But about talking about direction cosines, we have discussed about that they are the cosines of angle. Na? So cosine is what? Cosine of theta is what? Base upon hypotenuse. And if we draw a triangle here, basically, sorry, if we draw it further and extend it, this angle is alpha, and our base is represented by x2 minus x1 somehow. I will draw this is x1, this will be x2. So as per our discussion earlier also in the vectors, cosine is the unit vectors coefficients. How we used to find out the unit vector? By dividing the vector by its magnitude. So we have the vector, we have the drs. Now we'll have to divide it by the length of AB. What is AB's length? We'll use distance formula for this. Distance formula is this. X2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. Now for finding out the direction, cosines will simply divide x2 minus x1 on the length of AB, y2 minus y1 on the length of AB, z2 minus z1 on the length of AB. These are the direction cosines. Any doubts?
No, sir.
Simple. So let's now discuss about the next topic, which is condition for collinearity. Means if we have two lines, we can solve any 3D question with the help of vector or using the Cartesian system. And I will advise you to learn both so that as per convenience, you can use any of those two. However, you can, like, however the question demands and your intelligence recalls. Condition for collinearity. Collinearity means parallel lines. So if the lines are going to be parallel, we know the direction has to be same. So if the direction has to be same, we'll say direction has to be the same. We'll say that direction ratios are proportionate. Given dr of line 1 is A1, B1 and C1. And the dr direction ratios of line 2 is A2, B2 and C2. If the line are collinear or parallel lines, then A1, A2, B1 is proportional to B2, C1, C2. They're proportionate and equal to some scalar quantity. A is some scalar. And if the lines are perpendicular, then the sum of the product will be 0. If you ask me how, then remember the formula of angle between two lines, cosine of theta, which was the dot product. Let me explain this using vectors. So if line A1, B1, C1, so the vector is for the line 1's vector is A1 I cap plus B1 J cap plus C1 K cap. Line 2's vector is A2 I cap plus B2 J cap plus C2 K cap. The formula for the angle is L1 dot L2 divided by L1 magnitude L2 magnitude. Now when L1 dot L2 is A1 A2 plus B1 B2 plus C1 C2, because all those coefficients of I cap will get multiplied with I cap, J cap will get multiplied with J cap similarly. So the magnitude of L1 is A1 square plus B1 square plus C1 square. Magnitude of L2 is A2 square plus B2 square plus C2 square. Okay, anyways. So when they are parallel, then theta is 0 degree. Sorry. Theta, yeah. Theta is 0 degree and cos theta should be 1. So E1 plus A1 A2 plus B1 B2 plus C1 C2 divided by the magnitude should be equal to 1. And if we solve it further, they become proportionate. And here, when theta is 90 degrees, cosine theta is 0. If cosine theta is 0, then A1 A2 plus B1 B2 plus C1 C2 has to be 0. So that's the logic behind it. Any doubts?
No,
Any
sir.
doubts, Shalini? No. Okay, let's move ahead to the next topic. That is, now we are going to discuss about the direction cosines. This is the direct. This is the PYQ of NDA. The direction cosines of X, Y, and Z axis. So first, let's discuss about the x-axis. So here we are discussing about the line, whole x-axis. So x-axis is making what angle with itself? 0 degrees. X-axis is making what angle with y-axis? That is 90. X-axis is making what angle with the z-axis? That is 90. So cosine of alpha is cosine of 0 degrees 1. Cosine of 90 is 0. Cosine of 90 is again 0. So the direction cosines of x-axis becomes 1, 0, 0. Right? This is here we talked about x-axis. Similarly for y-axis, y-axis is making 90-degree angle with x-axis. With y-axis, it's making 0 degree with itself. With z-axis, it's also making 90 degrees. So the direction cosines, I should write there only. So the direction cosines of y-axis becomes cosine of 90, 0. Cosine of 0, 1. Cosine of 90 degrees, again 0. Now let's talk about the z-axis. The angle that z-axis is making with the x-axis is 90 degrees. The angle made with y-axis is again 90 degrees. The angle made by z-axis with itself is 0 degrees. So the direction cosines of z-axis are cos 90, 0, cos 90, 0, cos 0, 1. This is a previous year question. Any doubts?
No, sir.
Okay. That's an understanding of our that two parallel lines have same direction. Two parallel lines have same direction. So if there is same direction, then the direction cosines or direction ratios will be same. So the direction ratios or the direction cosines, I should say, So the direction cosines of a line parallel to x-axis should be the same as the direction cosines of the line that is of the x-axis itself, right? So let me save my work. So the direction ratios of lines which have the same direction, they will have same direction cosines. So that's why the direction cosine of any line which is parallel to x-axis will be the same. Now, if there are any questions, any doubts, any thoughts, please discuss. Any doubts?
No, sir.
Okay, then let's solve some questions. NCRT questions. So, if a line makes 90 degrees, 135 degree with the XYZ axis. Okay, so this is what? This is alpha. Angle made by the line with x-axis is alpha. Angle made by the line with y-axis is beta. Angle made by the line with z-axis is gamma, 45 degrees. We have to find its direction cosines. Very simple. What will you do? How do we find out the direction cosines, Yarini?
Sir, am I audible?
No, you were not audible.
No, I just said that we have to divide the like
Yes, yes, speak.
coordinates of vector
Yeah,
by
coordinates of unit vector. That will be direction cosines. Very right, very right. Coordinates, or should I write it in a different way? Coefficients of unit vector or cosines of angle made by line or vector that whichever we are talking about with axis. Here we are directly given the angles. So we'll simply take their cosines and we'll find out the direction cosine, right? Cosine of 90 degree. Is this thing clear?
yes, sir.
Yeah. So cosine of 90 degree is what? 0. Cosine of 135 means cosine of 90 plus 45 degrees. 90 changes it, sine 45 degrees. We know cos is negative in the second quadrant. So minus of 1 by root 2. Cos of 45 degrees, 1 by root 2. So these are the direction cosine. Read and ask if there are any questions. Is this clear?
Yes, sir.
Clear. I use this word clear. Means if this is a flower. Clear. Yes. Let's move to the next question. So we have to find out the direction cosines. Alright. We have to find the direction cosines of a line which makes equal angles with the coordinate axis. Okay. So alpha, beta, and gamma, they are all equal angles. Let me call it as theta. Okay. Because it's given and we are calling it as theta. We have to find out the direction cosines. Okay. So we know one thing about direction cosines, that first the direction cosines will be what? Here, cosine of alpha is theta na. Cosine of beta is theta only. Cosine of gamma, that is also theta. So these are the direction cosines. And we know one thing about direction cosines is that cos square of alpha plus cos square of beta plus cos square of gamma is 1. Here alpha, beta, gamma are all thetas. They are all thetas here because they are the same. We are calling that same angle as theta. So 1, 2, 3, 3 cos square theta is equals to 1. Cos square of theta is equals to 1 by 3. So cos theta will become plus minus 1 by root 3. So our direction cosines now become plus minus 1 by root 3 plus minus 1 by root 3 plus minus 1 by root 3. Is this question clear? Please read it from once and then ask if there are any questions. Any questions?
No, sir.
Okay. Next question then. These are NCRT questions. Very important. So if a line has the direction ratios, these, then we have to find out the direction cosines. So if direction ratio is given, so we know the vector will be minus 18i plus 12j plus, sorry, minus 4k. Its unit vector will be given by this, and its coefficients will only be the direction cosines. So we'll simply find out the magnitude, which is 18 square plus 12 square plus 4 square. 18 square is 324 if I'm right. 144, 16. This makes it as 160. This makes it 484, which is, I guess, 22. Yeah, 22. So the magnitude is 22. The unit vector will become minus 4 by 22. And these will be our direction cosines. We can cut them because they are getting divided by 2. So minus 9 by 11, 6 by 11, and minus 2 by 11. Is this question clear? I've solved it fastly.
Yes, sir.
Yeah. So from this question, we can derive a concept that if DRs are given to us as A, B, C, the direction ratios, then direction cosines will be A divided by square root of A square plus B square plus c square, and b divided by same a square plus b square plus c square, and c divided by a square plus b square plus c square. These are the direction cosines, of course, with plus minus sign. If we are talking about a line. Clear the relationship between direction ratios and direction cosines. Clear? Yes or no?
Yes, sir. Clear, sir.
Okay. Next question. So we have 3 points and we have to show that they are collinear. There are multiple ways to do that. So earlier also we have talked about the concept of area of triangle, that the area of triangle formed by three collinear points will be zero because that's actually not a triangle, that's a line. So line has no area. So that's one thing, that's one concept, that's one way that we can use. How we will find out the area of triangle? We'll find out the vectors. We'll find out that this is a point, this is another point, A, B. We'll find out AB vector and BC vector, and we'll cross multiply them. A vector into B vector divided by 2, that will be our area. That's one point. But as now here we are discussing about the 3D, so we'll use this method of direction, cosines, and ratio this way. So first, ABC, these are 3 points. First, let me find out the direction ratios of AB. So we have talked about it earlier as well. Whenever I have 2 points, then I'll find out the direction ratios by subtracting -1, -2. Same like as we do it in the position vector. -1, -2, -3. -2, -3, -5. 1 -4, minus of 3. Yes, we are doing it correctly. The direction ratios for BC will be 5 minus -1, 6. 8 minus -2, so 10. 7 minus 1, 6. So these are the direction ratios of AB, direction ratios of BC. If AB and BC are the lines in same direction, then their their ratios will be proportionate. So -3/6, -5/10, -3/6. If they are equal to some same scalar, then we can call that these direction ratios are having same direction and hence they are collinear. We have talked about this condition as well. So let's find out. This is minus of half. This is also minus of half. This is also minus of half. Yes, they are all equal and they are proportionate. So we can, hence it is sure that these A, B, C point are collinear. Understood?
Yes, sir.
This question, we have to find out the direction cosines this time. 3 vertices are given. 3, 5, -4. A, B, let me call it B, C, -5, -5, -2. Okay, so the dr of AB will be, let me find the dr of BA. The dr of BA will be -1, -3 BA. If I am finding BA, means 3 minus of minus 1, 4. 5 minus 1, 4. Minus 4 minus 2, minus of 6. So dr of, let me find of CB. Minus 1 minus, minus 1 minus 5. So that's plus 4. 1 minus minus 5, 6. 2 minus 2 minus 2 minus minus 2, 4. 3 minus minus 5, 8. 5 minus minus 5, 10. Minus 4 minus minus 2. Minus 4 plus 2, minus 2. So these are the direction cosines. Sorry, direction ratios. Now to find out the direction cosines, we'll divide it by the let's say if A, B, C are the direction ratios. So direction cosines A, B, and C divided by square root of A square plus B square plus C square and same stuff. So 4 square plus 4 square plus 36. So this is 16 plus 16 plus 36. So 32 plus 36, 32 plus 36, square root of 60. So 4, 4 minus 6 divided by square root of 68, 68, 68. These are the direction cosines of one line, of one side. Talking about the direction cosines of this side, mm, same, actually the same. So 4 divided by square root of 68, 6 divided by square root of 68, 4 divided by square root of 60. These are direction cosines of this side. Why have I written the same? Because 4 square plus 6 square plus 4 square is actually the same, equal to 60. That's why. Awareness. Here 64 plus 100 plus 4. So that's also 168. So these are the direction cosines of this. Any doubts? Is this question clear, Yarini?
Yes, sir. Clear, sir.
Great. 68 is 17 fours are 68. Yes. Anyways, we can solve it further also. My point is. Let's now jump to the next topic. As we have talked about the equation of straight line earlier as well. So let's continue the same discussion for finding out the equation of a line that is passing through a given point and is parallel to a given vector. That's the topic's name. We have to borrow something from the first page. So concept is that we have a line. We have a line, straight line, and on which there is a point given, and also we have another vector parallel to the given line. This is parallel to the given line. So let me call this given vector as B, and its coefficients, its vector are AI cap plus BJ cap plus CK cap. There's a point given on this straight line. Let me call this point as x1, y1, having coordinate x1, y1. The point is, let me call this point as A. For finding out the equation of this line, we'll take a general point. Any general point P. Oh, sorry, I've done a mistake. We're discussing about three dimensionals. So x1, y1, z1. Point P having coordinate as x, y, and z. Okay. Now let me draw vectors, position vectors for A and P as well. So this vector, let me call this vector as A. And this is a general vector. Let me call this general vector as R vector. And this is A vector. Sorry, A vector and R vector. Cool, cool. So we know that now we should find out the equation of this line. Okay. First is very first thing is very clear to us that the parallel vectors are proportionate. So here it is given that B vector is parallel to line. Let me take a vector from the line, that is AP vector. So AP vector will also be parallel to the B vector because AP vector is drawn from the straight line itself. Now that's why these both vectors will be will be parallel. What has happened to my tongue? Will be parallel. So B vector can be written as the proportionate. So lambda, which is a scalar, to AP vector. Is this thing clear?
Yes, sir.
Or I can also write it otherwise, lambda B, because 1 by lambda will also be another scalar quantity. Okay. So AP is lambda B. Now we have A vector, AP vector, and R vector. So let me apply triangle law of vector addition on triangle OAP. So what we'll see? A vector plus AP vector is equals to R vector because R is like naturally against the flow. No? R will be on the other side. R vector. We have AP, A vector plus lambda to B vector is equals to R vector. Now this is our equation of straight line. Where R vector is the general vector for straight line, like random point, any point on the straight line. And A vector is representing the position vector of the given point of the straight line, and B vector is the given parallel vector. So this is the equation of straight line in vector form. Are is everything clear till now?
Yes, sir.
Great. So let's convert this in Cartesian form. We know A vector here, A vector here is x1 I cap, y1 j cap plus z1 k cap. B vector is ai cap plus bj cap ck cap. R vector is the general vector xi cap plus yj cap plus zk cap. Let me replace everything. Next page. So this becomes xi cap a vector, that is a vector plus lambda b vector is equals to r vector. So xi cap plus yj cap plus zk cap, actually a na, so that they will be x1 I cap plus y1 j cap plus z1 k cap plus lambda into b. B vector was a b. So lambda into a I cap plus lambda into b j cap plus lambda into c k cap is equals to r vector, that is x I cap plus y j cap plus k cap. Taking common I cap, so that becomes x1 plus lambda a1. Or let's do one thing. Let's do one thing. Let's bring all the values with lambda onto the, let's keep it in the on the left hand. Let's bring everything other than lambda onto the right hand side. Okay. Lambda to ai cap plus bj cap ck cap is equals to x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap. Now, if we multiply lambda with every term inside, so from here, what we can get, that lambda a, if we are comparing I cap with I caps, right? So lambda a is equals to x minus x1, lambda b is equals to y minus y1, lambda c is equals to z minus z1. Okay, let's find out the value of lambda only. So we'll bring the a onto the right hand side, b on the right hand side, c on the right hand side. So it's all equals to lambda. So I can write lambda is equals to x minus x1 divided by a is equals to y minus y1 divided by b is equals to z minus z1 divided by c. And this is the equation of is the this is the equation of straight line in Cartesian form. This is the equation of straight line in Cartesian form. Where A, B, and C. Then we use another pen. Where A, B, and C are the direction ratios of parallel vector, and x1, y1, z1 is the given point on straight line. These two things only we require. That where A, B, C are telling us the direction of the line, and x1, y1, z1 are telling us the exact point on the straight line. These two things are only required. And lambda is the scalar. We don't care about that. It is just an expression that x1, x minus x1 divided by a is proportionate with every other. This is the Cartesian form of equation of straight line. Very important to understand. What's important to understand that what is what? X, Y, Z are the general point, any point on the straight line. X1, Y1, Z1 are the given point on the straight line. And ABC are the direction ratios of the line or the vector that is parallel. Basically, ABC are giving us the direction of the line. ABC, instead of ABC, we can also write the direction cosines of the line or direction ratios of the line or the direction ratios of the parallel vector to the line. We only care about the direction here. X1, Y1, Z1 is the exact point on the straight line. Understood?
Yes, sir.
Okay, then let's solve a question. See, NCRT is also talking about the same. That element can also be the direction cosines. We don't care. We just care about the direction, that we have to get the direction in the denominator part. We have to, sorry, we have to find the equation. Wait a minute. We have to find the equation of a line that passes. Simple. Everything is given in the platter. Equation of line is passing through this point x1, y1, z1, and this is the vector parallel. So this is the ABC. X minus 1 divided by a, y minus 2 divided by 2, z minus 3 divided by minus 2. This is the equation of straight line. Clear?
Yes.
Any doubts? No? Yeah. So if we have to find out it in the form of vector, then we'll simply do is equals to lambda, and then we can also find it out using this or directly, that r vector is equals to a vector plus lambda b vector. Now what is b vector? Is this a vector will be this. So 1 I cap plus 2 j cap plus 3 k cap lambda 3 I cap plus J cap minus 2k k cap. That is the R vector. Simple. The equation of straight line in vector form. Great. Clear?
Yes, sir.
Understood? Yeah. So let me make the heading. This time we'll discuss about the equation of line passing through two given points. Now let's draw diagram. Okay, so there's a straight line. Nice. There's a straight line, and 2 points are there on this. X1, Y1, Z1, X2, Y2, Z2. These are the 2 points given. So, as per our previous equation only, we'll find it out easily. We have taken 1 point, and that point is lying on the straight line, so that's not a problem. In the denominator, what we used to write is the direction ratios of the line of the direction. We just wanted to find out the direction, and we knew, and we have discussed it, that how we have to find out the direction of a line when there are 2 points given. Simple, by subtraction, na? Direction ratios of AB will be x2 minus x1 and y2 minus y1, z2 minus z1. So we'll write the direction ratios, and which will give us the direction of the line. That's all what we want. Simple. X2 minus x1, y2 minus y1, z2 minus z1 equal to some scalar. That is the equation of line which is passing through two given points. Clear? Understood? Earlier, what we were talking about, this vector was giving us the direction. This vector was talking about the point which is exactly there on the straight line. As we do not have any vector which is giving us the direction straightly. First, let me talk about that OA vector is this A vector, OB vector is B vector. Okay. So that vector that will be giving us the direction will be this vector, AB vector. So AB vector will be simply B minus A. So lambda into B minus of A is simple equation of straight line in the form of vector. Understood? Should I explain it again?
No, clear, sir.
Great. So let's now talk about the angles between two lines. Angle between two lines. angle between two lines. So what we care about when we have to find out the angles between two lines, the direction, their direction. So we have, if we just have the direction of both of the lines, we'll be able to find out the angle. Okay. So by direction, what do I mean? Either we have the direction ratio or we have the direction cosines. If we have the direction ratios, let's say A1, B1, C1 are the DR of line 1 and A2, B2, C2 are the DR of line 2. Then the angle, the cosine of angle between them, simply A1, A2 plus B1, B2, C1, C2 divided by A1 square plus B1 square plus C1 square, A2 square, A2 square plus B2 square plus C2 square. We do not care about the exact point on the straight line. We just care about the direction ratio for the direction cosine. If we have the direction cosine, let's say L1, M1, and N1, the direction cosine of L1 and L2, M2, and N2 are the direction cosines of L2. We can apply the same formula. As we know, square root of L square plus M1 square plus N1 square is 1. So that's irrelevant to write. So cos theta is simply L1 L2 plus M1 M2 plus N1 N2. Now, this might be, you might be wondering how, but why? Okay. So actually what we are talking about in like equation of a straight line, A plus lambda B, where B is the vector. B is the vector talking about the direction. Let's say this is the equation of straight line 1. This is the equation of straight line 2. So actually what we have to find out the angle between B1 and B2 only now. So we know cosine of theta. If we have to find out the angle between two vectors, we take their dot product, divide them by their magnitudes. This is exactly that we have done here, here and here. Understood?
Yes, sir.
Okay. From here we derive the concept that if lines, this is important and easy. If lines are perpendicular, then cos theta, cos of 90 degrees is 0. 0 is equals to A1, A2 plus B1, B2, C1, C2. If lines are parallel, or we call them as collinear, so the DRs become proportionate. Lambda is any scalar. Clear? Understood?
Yes, sir.
Okay, cool. Okay, we have discussed about vector form and the Cartesian form as well. Now it's time for us to understand about the shortest distance between two lines. So as we are talking in the two-dimensional phase, that every two straight lines have only two contingencies when it comes to the intersection or the distance between them, is that either they intersect or they remain parallel when we are discussing about two-dimensional plane, two dimensions. But if we start discussing about three dimensions, then there is another contingency that those two lines are not parallel, not intersecting, but there is this third possibility of skew lines. Skew lines. They will never intersect each other, nor they are parallel. Neither they are intersecting nor parallel. These lines are called as skew lines. Let me write skew lines. And if that is so, so let's find out the SD, the shortest distance between skew lines. So let's say L1, its equation is given. Line 2's equation is given. Now the shortest distance between these two lines will be given by this formula. B1 cross B2 dot product with A2 minus divided by B1 vector cross B2 vector magnitude. This is the formula. And if lines are given in the format of Cartesian form, then first convert them into vector form and then apply the same formula. Because the formula for shortest distance in the vector form is comparatively easy to memorize. Very easy, very easy. That will look very awkward if you write it in Cartesian format or see in the books the formula. Now let's discuss about the second contingency, the shortest distance. Is this clear? Understood?
Yes, sir.
Distance between parallel lines. So parallel lines, there will be only one difference in their equation, that their directions will be similar. Oh, sorry. R will not have any because that's a general point. Na? We have same direction. Just scalars are different. Okay. So these are the equation of two parallel lines. So the distance, the shortest distance will be given by B vector cross A2 vector minus B1 vector. Its magnitude divided by B vector's magnitude. That's the shortest distance formula for two parallel lines, and that's the shortest distance formula for two skew lines. You have to memorize it. If the equation of straight lines are given in the Cartesian form, then first convert them back into the vector form and then apply this form. Understood?
Yes, sir.
Okay, let's solve the exercise then. Let's exercise our knowledge. There's a diagram of two screw lines given. Me share it. This is the diagram of two screw lines. They will never intersect. They are not parallel. First question. We have to show that these lines that we have, this is the direction cosine of line 1, direction cosines of line 2, direction cosines of line 3. We have to show that they are mutually perpendicular. If that is so, then let's call it as L1, M1, N1, L2, M2, N2, L3, M3, N3. Okay, so the angle, the line 1, L1, L2, for them, these two lines to be perpendicular, L1, L2 plus M1, M2 plus N1, N2 will give us 0. And for L2 for being perpendicular to L3, L2, L3 plus M2, M3 plus N2, N3 will give us 0. And for line 1 to being perpendicular to line 3, L1, L3 plus M1, M3 plus N1, N3 will give us 0. Understood?
Yes, sir.
Yeah. Let's solve it. L1, L2. So we know wherever we are multiplying two digits, 13 into 13, 169. 12 into 448 plus M1 into M. Uh, that is 3, no? That is minus of 3. So L1, L2 हो गया M1, M2 minus of 36 by 169 plus 169 minus 4 minus 3 minus 12. So plus 48 minus 13 6 minus 12 है, make it 0. L2 L3, so 4 3 ja 12 by 169 plus M2 M3 minus 48 divided by 169 plus N2 N3 36 divided by 169. 1236 plus 48 minus 48 becomes 0. LCM is the same, no? That's why. Similarly, for this, 12 into 3, 36, minus minus plus, minus plus minus, this cancels 0. Clear? Hence, it's proved that these lines are perpendicular, mutually perpendicular. Understood?
Yes, sir.
Let me find a good question. Every question is good. Now I'm trying to solve them in a faster way. So if you uh, lose the attention or lose the concept that how it's being solved, please slow me down. Let me know, okay? Show that the line through the points, one point, another point, is perpendicular to the line through the points. This is another line. So what we have to do is that there's a line 1 minus 1, 2, passing through 3, 4 minus 2, which is perpendicular, which we have to show actually. Line passing through 0, 3, 2, and 3, 5, 6. Okay. So we know if these two lines are perpendicular. So if we find out its dr and its dr, then there the product and sum, the drs will be 0. Okay, so dr of this is 3 minus 0 is 3 minus 0 is 3. 5 minus 3 is 2. 6 minus 2 is 4. dr of this is 3 minus 1, 2. 4 minus minus 1, 5. Minus 2 becomes minus of. Now the dr 3 into 2, 6. 5 into 2, 10. 4 into minus 4, minus of 16, which makes it 0. So hence, line 1 is perpendicular to line 2. Understood? Yes or no?
Mm, yes, sir.
Pakka? Sure? Are you sure?
Uh, sure, sir.
Okay. Hmm. I have found a good question. We have to find out the Cartesian equation of the line which passes through this point. So this is passing through this point. Okay, we have the passes point and is parallel to the line given by this. So if it is parallel to this line, so its direction and the line that we want to discuss, that the line of which we need to find out the equation, those direction will be same. So first, x minus is passing through this, x minus of minus 2, x plus 2. Y minus of 4 is equals to z of minus 5 plus 5. Now we have to give its direction. Now the direction of this line and the line that is parallel to it will be the same. So 3, 5, 6, same. Well, very simple. 3, 5, 6. These are the direction ratios which is depicting the direction of the line. Understood?
Yes, sir.
We have to find the Cartesian equation of a line. Okay, it's given. It's given. We have to find out its vector form. Okay, it's very easy. Uh, so it's passing through 5 minus of 4 and plus of 6. It's passing through 5 minus of 4 and plus of 6, passing point. And the direction ratios are 3, 7, and 2. R vector is equals to A vector plus lambda of B vector. This is for the direction, this is for the passes. So 5I minus 4J plus 6K cap plus lambda into 3I plus 7J plus 2K is the vector form of the straight line. Understood?
Yes, sir.
Yes. Now, next question. We have to find the angle between the following pair of lines. This is the equation of line 1, the equation of line 2. See, this is the A part. This is the part, this is the B vector, which should be giving us the direction, and this is the passing point. Okay. So what we need to discuss about actually when we have to find the angle, the direction only. We don't care about whether it is passing from where to where. We just care about the direction. Okay. So let's bring the DRs 3, 2, 6. DR 1, 2, and 2. Formula A1, A2 plus B1, B2 plus C1, C2 divided by square root of A square plus A1 square plus B1 square plus C1 square 9, 4, and 36. 1 plus 4 plus 4, 7, 12, 19. 30 and 36, 49. Square root 7, 9, 3. So cos theta is equals to 19 by 21. Theta is cos inverse of 19 by 21. Clear? Understood?
Yes, sir.
Is the music audible in the background?
No, sir.
Was it earlier?
No, sir.
Okay. Bad for you then.
Why, sir?
Okay, I'm just kidding. Actually, I like it. So, like, have you heard Haryani music?
No, sir.
No. Okay, कोई बात नहीं. It's okay. So, I like actually I live in Rajasthan, but whenever there is any program and someone has to dance, then it's only the Haryani or the Punjabi music which is there for you to dance. Otherwise, all the music is just like plain for you to dance.
Oh, okay.
Yeah. So this time we have to find out the angle between the following pair of lines, and Cartesian, the equation of line is given in the Cartesian form. Okay, so what we care about is the direction only. Direction ratio is 2, 5, and minus 3. Minus 1, 8, 4. Formula A1, A2, B1, B2, C1, C2. 2 square 4, 5 square 25, minus 3 square plus 9. 1 minus 1 square 1, 8 square 64, 4 square 60. So that becomes 40 minus 14. That becomes 26. Yes. So 24 plus 30, 25 plus 13, 38. Yes. And 64 plus 16 becomes 80, 81. 81 square root is 9. So, so cosine of theta is equals to 26 on 9 to 38. Our answer. Correct. Understood?
Yes, sir.
We have to find out the shortest distance between the lines of which vector form is given to us. Now here we can observe that these two lines are not parallel. So the formula for shortest distance is B1 cross B2 dot A2 minus A1 divided by B1 cross B2 vectors magnitude. So from here it is clear that we need to find out B1 cross B2 and A2 minus A. So A2 minus A1 is simple. Let's consider it as line 2 as line 1. So A2 minus A1 vector is 2 minus 1, 1 I cap, minus 1, minus 2. Sorry, minus 1, minus 2, yes. Minus of 3j cap. Minus, minus 1, minus 1. So minus 2k cap. That is A2 minus A1 vector. Let's find out B1 cross B2. B1 vector. That is 1 minus 1 plus 1. B2, 2 plus 1 plus 2. Minus 2 minus 1 minus 3. Plus 2 minus 2, 0. Leave. Plus 1 plus 2, 3. Okay. So minus 3 I cap minus plus 3k cap. The magnitude will be minus 3 square 9 plus 0 square 0 plus 3 square is 9. So it's actually 9 square root 2. Sorry, square root of 9 is 3 root 2. Clear? Now let's find out the shortest distance. Dot product with A2 minus A1. Divided by 3 root 2 whole modulus. So minus 3 into minus 1, 0 into 0 into minus 3, 0. Plus 3 into minus 2, minus of 6. 3 root 2 comes out as minus 9. 3 root 2, 3 cancels, minus 9 by minus 3. Shortest distance becomes, because there is a modulus, 3 by square root 2 units. Understood? Yes or no?
Yes, sir.
So that's enough. We have talked about, I guess, every kind of question now. Shall we take more example or move to the next topic? Yarini,
Uh, anything is fine, sir.
anything. So let's take a test of you. That would be fine.
Okay, I'll try my best, sir.
Have you studied? Which chapter have you studied till now?
Sir, I've just started from the basics. I didn't go for any complicated topics and all.
Let me